Hello everyone, and welcome to today's webinar, which is titled Graphing in Excel Intermediate and Advanced Techniques. My name is Jim Kaplan. I'm founder of AuditNet, and with us today is my colleague and friend Richard Lanza, an ACL and audit software expert. This webinar represents a collaboration between AuditNet and AuditSoftware.net in delivering training series focusing on audit software. We're really glad that you could join us, and we wanted to wish everyone a Happy New Year, those of us that haven't been with us in a previous webinar this year. So I will be moderating today's webinar. A little bit about myself. For those of you who don't know me, I'm the founder of AuditNet. The background is a CAE, Internet for Auditors pioneer, and an auditor who believes and promotes the use of technology for audit. The next slide provides a little bit of information about AuditNet. Before we proceed to today's material, however, and introducing our presenter, Rich Lanza, I'd like to go through a few important housekeeping items. This webinar and its material are the property of AuditNet and Cash Recovery Partners. Unauthorized usage or recording of this webinar or any of its material is strictly forbidden. We will be recording the webinar, and you will be provided access to that recording within 2 business days after the webinar, and that may take a little longer depending on how soon we can get it uploaded to the site, and that will be available to those who have paid for today's webinar. Downloading or otherwise duplicating the webinar recording is expressly prohibited. Please complete the evaluation to help us continuously improve our webinars. You will be receiving a link to an evaluation questionnaire afterwards. Reminder, you must answer the polling questions because this webinar does qualify for CPE credits. We will be putting up polling questions related to the material covered in compliance with NASBA rules. The question period will remain open for several minutes, so it's important that you respond. Those answering the questions will receive their CPE certificate by email within 7 to 10 business days. This applies only to the live session, as we're unable to offer CPE for the recorded webinar. And also, if you didn't pay for today's webinar, you will not be receiving CPE. Unless we've made arrangements beforehand for that. We will take your questions during the webinar. Submit your questions via the chat window at the lower right-hand box on your screen. Type your question and press return to send it. Any question we're unable to answer by the end of the webinar, we will get back to you within 48 hours. Some additional technical items. If you're having trouble with the webinar software, check to see if Java is enabled and whether you have any pop-up blockers disabled. If you're still not able to get in to get the webinar to function, please log out and log back in again. If you can connect to the webinar in the audio portion but get kicked off at any time, just reconnect using the same steps you used at first. Thanks again for joining us. Without further ado, I'd like to turn the floor over to Rich Lanza to cover advanced graphing techniques in Excel. Rich?
Thanks again, Jim, and thanks everyone for coming today. You know, for the most part, I feel like I'm still a bit of a novice to intermediate when it comes to graphing, even though I've been doing it, God knows for how long. You know, probably back into Lotus's days. But with that said, you know, I find that graphing is something that really can very quickly bring to light audit issues. And I actually now use a lot of graphing on top of all of the query reports that I run. So I may run a lot of reports to identify duplicate payments and journal entries posted on a weekend and all those other things. But what I like to also do is a bit of a data mining exercise using graphing, visually kind of looking at it and making changes to it from a graphical point of view, and then selecting items. So we're going to talk about that today. We'll also be joined by Dean Brooks by video only. Excuse me. He will be helping out through providing some discussion around log usage and how, you know, changing your axis in the graph can really you know, change a lot about the actual presentation. So learning objectives for today. I wanted to follow up to a course that we did back on February 23rd, and we'll kind of go to that at some point just so you can see some of the videos there. But with that said, we're going to add a lot of best practice tips, and what I've tried to do is add a bunch of them up front and then what we'll follow that with is a couple of other topics like the log axis topic from Dean Brooks, Geo Mapping, also taking a look at Benford Law scoring and graphing of that, because Benford's Law is such a interesting concept, but to look at it in a graphical way is kind of interesting as well. So we'll be doing that more in case study type format. You will get all of the files that we will be going through today. So in a way, I actually come preloaded to the actual event so that we have all of the data files ready and set up, and makes it a lot easier to discuss. So you'll have that too. Yeah, give us about 2 to 7 days to get that up, but I do expect it to be up sooner than later on Audit Software Videos, and we'll show you that in a little bit. Last but not least, I wanted to talk to you about how there are various ways of changing charts and the features within those charts, and how you really can kind of change a graph from being very ho-hum to being a real presentation tool. And we're going to put those together into a bit of a toolkit, as I'll show you, that if you put data in one place, you can get all of this different analysis in one go, and we'll talk about that as well. And that's kind of that middle learning objective there, be able to build a tool set of these pivot tables and charts. Okay. So I figure we'll probably go for about 90 minutes or so, and then have time for polling questions and also questions towards the end. You're welcome to post your questions. I just want to check here. I think we have one. Yeah, okay, so before we got started, I just wanted to make sure there wasn't anything someone was saying like, I'd really like to focus on this. Okay, great. So with that said, please post any questions that come through, and what I'll do is I'll get started with some of the best practice discussion, and then we'll move forward into some of these case studies like we talked about. Okay, just give me a second here to get started. And okay, so best practices in graphing, and more from an advanced point of view. What I want to do is first off show you how I like to build a bit of a graphing / pivot table toolkit or workbook in Excel that has a nice nomenclature as to where you're putting your data, where you're putting your pivot table, where you're putting your chart, and we'll talk through a couple of examples there. And then we'll also talk about how you could kind of auto-populate and then filtering graphs, which I find either doing it through pivot table filtering or through the actual static I guess file that we have that you may have graphed in kind of a static object. We'll show you the difference of what I mean there. But in either case, you can filter, and I do want to talk through that as well. So I'm going to dive into the actual Excel now, and so bear with me 1 minute as we switch over. Okay, so I have a few graphs here, and we're going to work with these tools for the moment, and we may move on to others as time goes on. I have about 4 or 5 files that I hope to show you today, so bear with me. But so bear with me just 1 more minute. I just want to get my screens a bit organized here. Okay, so first off, I was going to dive into this payable sample pivot table. And head over to the payables data. Now, I almost want to, in some way, maybe make a tab color for this as being the full data. So, make that one a blue with a white or something like that, so you really know that that's the data that you're going to be using in your pivot table. We then create pivot tables off of that this one just being on the first digit of the Benford's number. We calculated that in this spreadsheet here, and again just carried it forward. Don't want to really make it a course about Benford's law or anything, but excuse me. With that said, this is then kind of a pivot table or an application, or however you want to call it, a middle layer in between the data. Here's your calculations, and then here's the graph, and here's the chart. So this may be a way for you to document anything basically that's blue and has data after it. I know is the full raw data from a nomenclature point of view, and then anything that just has like a name to it is in essence something that is more of a calculation. But anything that has chart at the end of it would be an actual chart. And there's ways to organize this better, maybe put all your charts together, or however you want to do it, to present things. But it kind of goes to the theory here that if you could learn just how to pivot table in Excel, and we'll do I'm sure a few just in this graphing session. Not that it's a pivot table discussion today, but just to show you some pivot tabling. I think what you'll find is that you could build a toolkit that could auto-populate. And so again, first I wanted to get the nomenclature down of these three different types here, and then just kind of moving on here back to this payables data. So this is where I wanted to kind of show you what we learned the last time. And this is actually a free video out on Audit Software Videos. So this was the past course that we did on graphing. And in here we have this pivot getting all of your data, learning object. And okay, so why am I showing you this? For mainly to kind of to note to you that first, hold on one second, that we actually have it out on the web, and you do have all these learning objectives of the previous course, and AuditNet has a discounted link, and we can get that to you for that if you haven't seen this course, or if you haven't signed up for this. But this is just in video form, and a lot of this talks about some of the more basic things that I'm not going to talk about today, such as like building a basic pivot table, etc. But if you go to the home page, just from a free point of view, and somewhere in here we have view a sample Excel video. What you can do is play this pivot all data video, and just going to mute that. What basically this talks about is how you could set up a pivot range, named range, and I'm just going to skip through this thing so I don't want to waste your time with it. But here is basically the main premise, is that that pivot range that we set up needs to equal this formula. And you copy it every time. There's no, it's just literally copy it in some way and save it and then use it. And what's really nice about that, and just again, to get to this video, you just go to free videos on Audit Software Videos, and you can check that out. Is you can create a named range that will dynamically change as you put data into this toolkit. So in essence, if you do add a few more columns to the end of it, all of your pivot tables really still should run, because they still usually have all the old data fields in here somewhere. And because it's dynamically refreshing by pivoting for all of the data per that video, it'll basically dynamically figure out, well, I need to go to basically column P and row 4822, and if you added more columns, it would dynamically kind of grow to whatever that is. What that allows you to do is when you set up your pivot tables, instead of setting up the let me just find this here. I guess you can't get it through there. So in changing the data source from your pivot table tools, you would actually enter that pivot range in here, and you'll see what I'm talking about in that video. but it'll be more of a dynamic range instead of this fixed range that we have here. And that will then capture all of the data, for purposes of, the pivot table, but then, more importantly, all of the charts that are based on it. So, what I like to do, and this is probably not the best example, but notice how I have all these charts that have been developed in here. Once you've developed kind of that data engine that's going to always import the data that's available to it, once you have that, all of these charts will work, and because all the pivot tables will work, and they're based on, the charts are based on these pivot tables. You can build a pretty intricate set of graphs, and we're going to talk through these, but you could have probably 5 or 6 of these analysis kind of ready to go, and as you import the data, for the most part, I'm trying to think here. I think you just you go to this Benford number. In your pivot table tools, you hit the refresh button, and it would basically refresh this data set for purposes of using it. So, okay. I just want to get out of this spreadsheet here, so I go to View, Range All. That'll be great. Okay, perfect. So what I also wanted to show you is how to filter. And, we're going to talk about a few of these, graphs, but for the most part, the filtering capability, I'm just going to turn off the filter and just say select all for a second here. That will change, at least, well, let's look at it here. I'm pretty sure that this one is hooked up to that data, so I'm pretty sure. So what we'll do is to prove that, I'll just even say top 10. Yeah, so this is dynamically set. So what I wanted to get at, and just wanted to make sure that my actual graph was set up to the data properly here, was if you ever set up a filter on the data that you have graphed, it becomes a really nice way for you to filter on that data and be able to, either probably the easiest way would be, greater than or less than or equal to, and get something more relevant, for graphing purposes. Then go into your scatter value volume, and I think both sides of this should, be just taking a look now at that new set of data that I've allowed into it. All right. Another way to filter, and something that I will actually go back to my payables one, and again, all of these are kind of preloaded, for you to take a look at. Right. So, in your actual, any sort of pivot table that you may have, you can actually, again, I'm not going into all the pivot table, easy stuff. I'll just kind of show you more of the advanced stuff at this point. You can, in this one, as you'll see in a minute, this has everything in it. It has 2009 through 2011. And then if I go to the Stratify 2, you'll notice that I've actually gone into this filtering and taken away basically 2009, anything prior to March 24th, 2009, and then included anything greater than 2010. And that provides you with a more filtered view. Now, this is linked to this Stratify chart, and again, just to prove the point, I could take away 2011 and really just look at 2010, and now I'm just looking at 2010 in this chart. So, if you didn't realize that that was there, the filtering capability of Excel is quite interesting when you're graphing, and really when you want to look at pockets of areas, like you might want to look at the small stuff separately than the big stuff, and that will come through in a couple of case studies that we're going to do a little bit later this morning and afternoon. But for right now, you'll kind of get the sense of why we're filtering and setting up different axes along the way. Okay, so. I'm just going to bring over this slide just to show you where we are in the slides. I really just had one slide, and then I'm going to jump right into the case study of it. But this is sort of another best practice in my mind that really isn't even using graphing, but is, and it's basically using conditional formatting on data, but looking at it in a very small kind of way, and all of what I'm saying will make a lot of sense to you in just a minute here. So let me jump into Excel, and just looking for any questions. Doesn't seem like anything new has come through, but if any questions come through as I continue on here, please let me know. In the meantime, let me jump into Excel. Okay, so what I wanted to show was I had basically created a pivot table, and it's really small, so let me scroll into it so you can actually see what I've done. It doesn't really matter. I just wanted to kind of show you obviously what I'm doing here, but it could be with anything that you're doing from a graphing point of view. On your rows and labels, I have journal entry number, and on the columns, I have the account numbers that journal entry is posting to. And in many cases, it's basically anything. In this particular filter, I believe I have it. It's between I think it's like 1 million and 50 million or something like that. So it's stuff that's material, and that's kind of a way of, obviously, as we showed just a second ago, how you can filter things out. But just imagine, again, this is journal entries down the rows here, and these are the journal entry or general ledger account numbers that are being posted to. Okay, so now I'm going to scroll out, and you'll notice here that there's red and yellow and green throughout, and it's something where this provides you almost a map of where things are big and small and that kind of thing. So how did I do this? Essentially, at a very, very small level, which I'm at right now, probably too small to really be of much use in a lot of ways, is let me scroll back into it just so I can, sorry. All right. So if I just go right into the data area itself and make sure I'm kind of, oops, sorry. Okay, so not taking any totals into account, but sort of everything else. Now I'm just in the data section. I'm not the rows, I'm not the columns, I'm just the data in the middle. You can go to your home menu or part of the ribbon, go to conditional formatting, color scales, and select one of the color scales. It could be red, white, blue, green. I did it green, yellow, red. And what it's basically telling you is that the yellows are sort of in the middle. The green is very large, and the reds are very small. And it's interesting, now that I'm looking at my journal entry activity with the general ledger accounts here, you can almost see pockets of large entries, and anything that would be green, which would be this item here as I scroll now into it, all you have to do, by the way, is if you select an item, like if I select that green item there and scroll in, it's going to scroll right to that item. So 38 million is probably one of the largest items in here, and let's look for the more red item, and probably I'm going to have to drive on this one because you probably can't really see my screen that well. The smallest one seems to be like maybe $3,000 that's in there. Largest one, again, would be the most green, and I think it was in the millions of dollars here. 38 million there. So okay, so that provides you the range. But what's more important about this, and again, it might take a little bit of thought and just take a look at, maybe how many yellows are there, how many reds, and how many greens there are. It probably fits more of like a standard deviation or some sort of, gets closer to the average with a few outliers. But if you pulled some of those outliers, this sort of graph not only, it's basically a pivot table with conditional formatting. It provides the data label, but also, as you go into it, let's say that really large item, let's find it, I think it's this one. Well, this one's 22 million. I'm pretty sure, unless I'm, maybe I've made this its own. No, I'm pretty sure that that's still a pivot table, so if I double-click onto that, it will drill down into the activity that's making it up in the first place. So that's something where, again, I think it's a very powerful quote-unquote graphing technique, but yet it's using pivot tables and being able to very quickly kind of format and get down there. But, how do we get there? This could be done on any pivot table. I just think it's a way of almost graphing and providing the data labels at the same time of the particular information that you could then drill down on by double-clicking on. The way we got there was conditional formatting, by formatting all the data. And you have a lot of different options here. I mean, I urge you to kind of take a look. I mean, they have all the data bars. That might be an interesting way to look at it. But I like the colors, and there is a way somewhere in here of how to filter by color and sort by color, so you can kind of have a little bit of fun with that as well. Okay, so it's about time for that first polling question. So I'm going to launch that. Hopefully everyone will see that. Which Excel tool most easily allows color filtering in data sets? Is it account mapping? Is it pivot tables? Is it insert shapes? Or is it conditional formatting? So we have a poll open. If you could select one of those options, we'd appreciate it. I'm just working on something else in the meantime. We'll give everybody a minute to fill that out, and it's only been about 40 seconds, so. Okay, so let me then change this poll. I'm going to close that poll. Almost everyone's voted, and I will share that with everyone. And yes, conditional formatting, the thing we talked about just at the end there, would be what you would use, and would be something that would allow you to more or less filter, and also by color coding the filtering. So let me just get on to the next section. Bear with me just a minute here before I bring you all back. Okay, sorry about that, everybody. I was just getting set up. Basically, have Dean Brooks, who is a mathematician friend of mine and somebody who has worked quite a bit in the audit field, but as more of a statistician, and just showing us some basic graphing techniques, but more so in changing the access to more of a logarithm. And again, Dean has a great way of presenting it. So I'm going to kind of switch over here, so there might be just a quick lag here in the sound or something. But when I do, Dean will basically be talking to you. So give me a second here.
All right, I'll start by introducing myself. My name is Dean Brooks. I am a freelance analyst and statistician at a little company called Ecros Analytical. My topic today is choosing better samples by understanding size laws. Now, what I'm going to do is I'm going to explain how to display financial data in a way that makes it easier to see the relationship between the dollar values and the sizes of vendor organizations. And I'm going to explain why you would want to do that, why that's a useful thing to do from an audit perspective. And then I'm going to show you how to do it in Excel. And this is not something that's commonly done. There will be some sort of novel concepts, things like logarithmic scales, which auditors don't want to deal with. But we'll go through this step by step. And since we're only going to deal with one example and one fairly straightforward idea, I don't think that there'll be anything here that the math phobic will panic at. So let me talk about the title for just a moment here. A size law is basically a relationship between items in a set or items in a database. So you have a file, you have a set of financial transactions, you have all the bills from all your vendors. And the size law says how many of the bills are small, how many of them are large, or it says how many come from small vendors, how many come from large vendors, or, and this is the tricky part that we're going to deal with today, you can have a size law that relates two variables together. So it says how many small bills come from small vendors and how many large bills come from large vendors. So you get a more complex kind of size law that involves more than one variable. So we're going to be dealing with size laws, and we're going to be dealing with how to display the information in a way that makes sense. Okay, why are we doing this? Why do you care? As auditors, I'm sure you're familiar with sampling, and I'm sure you realize, this is news to you, sampling is relatively inefficient. When you run any kind of test on audit data, any kind of large corporate database with tens of thousands of items, the test will produce thousands of red flags. It might be 7% of the total, it might be 5%. It will vary depending on the test, but it will be so many that there's no chance at all that you will be able to look at all the flags. You will never, be able to pull up manuals or read line item by line item all the items that are flagged as suspicious, just problematic. So you, of course, have to sample. And typically, the sampling is relatively random. You just pick the items out of a bin, or you weight them by dollar value. Either method is a random way of deciding how to proceed. And if you find an actual problem by that method, it's a little bit like holding a lotto ticket. It's like, you had thousands of items, and you managed to find one where there was an actual fraud. And, there aren't all frauds. Fraud is still relatively rare. So you're doing very well to do that by this method. What we'd like to do is we'd like to understand the structure of the data. We'd like to understand these size law relationships, and then to choose our samples more scientifically. I'm not even going to talk about the actual sampling process today. I'm not going to go that far. All I'm going to do the relationship between the variables. So it's like the first step in making your sampling better. All right. So this is also not new if you spend any time looking at data. Financial data is highly skewed. And all that we mean by that is that the values have a large range and they're not evenly distributed. So for example, in a corporate database, invoices that are worth $1, we have invoices that are worth $10 million, and the proportion is not even. There are a lot more dollar invoices than $10 million invoices. Similarly, if we're looking at vendors, you can have a vendor who only bills you once a year or once in its entire history. Or you have a vendor who sends you 1,000 invoices or 1,000 a month. And again, that distribution is typically skewed towards small vendors. There's a lot of vendors who send you 1 or 2 invoices in the course of the year, and relatively few who send you 1,000. So this means that most of the activity in your file is relatively small and not really material. I mean, it's not really a success to detect an error in a dollar invoice. It might be a symptom of something serious happening elsewhere. If there are enough dollar invoices that are wrong, that after a while turns into real money. But this is a problem that really doesn't have a solution right now. It really is not handled well in the audit community. Because what you're trying to decide is whether to look at problem items, whether to search simply for an individual invoice out of context that is bad, or whether you're looking at problem vendors, and whether you would have greater success by trying to identify those vendors that generate duplicates or fraudulent. And it's a subtle problem, and I hope to impress upon you in the next 15 minutes just why it's not handled well and what sort of thinking you have to engage in in order to handle it better. So as I was saying, we need more insight into this data pattern before we can even hope to devise a better sampling plan. Our objective for today, just to reiterate, is not to do a new sampling plan, but just to look at the data in a new way and to realize that there's something going on here that we haven't understood very well and we need to understand. It's not just that the range of values goes from $1 to $1 million. And it's not just that vendors go from, single-time vendors to vendors with thousands of transactions. It's the fact that those two variables have a relationship, that the number and size of individual invoices vary with vendors. So a large vendor handles invoices in a different way, and the data has a skew, it has a trend, it has a size law that we need to know. It ought to be something that's in our minds as we're preparing our sampling plan. It ought to be in our minds as we're trying to decide, for example, whether we're trying to find a problem vendor or a problem item. So that's what we're going to try and accomplish. I'm going to take you into Excel in a moment and show you some graphs. We're going to try and find the typical relationship between invoice size and vendor size. We're going to display that relationship using a log-log graph. And that means that the two scales, the X and Y scale of the graph, are going to be logarithmic. I'm going to define all these terms, and I'm going to show this to you firsthand in a moment. But that's going to be the big takeaway from this lesson, is that you're going to look at vendor size versus invoice size on a log-log graph. And you're going to hopefully be enlightened about just how complex your data is. And this won't get us to better sampling. In one day, we really can't do that. In a half hour, we really can't do that. But it will lay a foundation for thinking. It'll motivate you, I hope, just to start looking for better ways to sample. So here we are in Excel. We have a sample data file. This is from a big Fortune 500 vendor, or rather Fortune 500 company. It's vendor data for a year. There are about 3,600 vendors in this file. And you can see by the dollar values that the total is in the billions. It's a very large company. What we've plotted here in these two columns, or rather these three columns, Column C, column C, it is the number of invoices submitted by a given vendor. Column B is the total dollar value for the year covered by those invoices. And then, of course, column E is just the average value. So we have $848 million worth of transactions for the largest of the. And that was broken down in 19,619 individual invoices, and thus the average is about $43,000 per invoice. Now, the first thing I want you to notice is that there's some extreme variation even in this tightly knit group of high-value vendors. Now, there's no vendor on the page right now that didn't do at least $24 million of business. That's, that's the high end. There's not a lot of people who have that kind of relationship. But even in this group, we have one that did 19,000 individual transactions, and then a little further down, we have one that did 22. There's one with 10,000, there's one with 53, 11,000, and 60. So it's not obvious just at a glance what the trend is, what the relationship is between the number of invoices and the total dollars. It's not something you can just guess by looking at the data. And I'll just scroll up a little bit and you can see. Here's $19 million worth of business, 3 individual transactions. Just scroll a little further. You can see it going up and down. You can see the variation. 3,800 different transactions, $10 million, 85. And this persists all the way down. There isn't a point where you stop having this kind of variation. There's 3,000, there's 11. See what I'm saying? It is a very, very random relationship. At the first glance, there's no pattern. There's no rule. Oh, you see now, here's a vendor. It's the highest value single invoice vendor in the set. This vendor did $2.2 million worth of work and charged it all to one invoice. So we've got this data set. I'll just scroll through a little bit more of it. You can see I've sorted it, and you can see that eventually, when you get down low enough, these numbers start to come down. But here's a $42,000 vendor, and he submitted 866 individual invoices. Now this is expensive in terms of processing. This is like $49 worth of invoice, and then who knows how many dollars worth of processing costs. So these are important items to notice too down here at the bottom or further down. If we go down to the very bottom, we get to all these vendors with one invoice each. And there are many of them. There are hundreds of them. There are probably, if we have from 1 to 5, there's thousands of them in that range. So we have this very unwieldy data set. We want to know what the pattern is, and we think maybe we could learn something by graphing. Let me show you what happens when we graph it by the normal Excel. Now this is the standard linear scale, both in Y directions. You see you've got number of transactions at the bottom, and as we saw, it looked like the largest was somewhere in the range of 20, and that's confirmed there. The total vendor volume, I've actually omitted a couple of the very top ones. If you look closely, if the top of the scale was $200 million, and we know that there was at least one vendor that was above that. So I've cut off the top scale to try and make this a little more readable. But I haven't succeeded. If you look at the plot of points, it's really not very informative. It really doesn't tell you a whole lot. Now, Excel provides various trend tools. You can just say, I want this graph to have a trend line. And in this case, I've asked for the linear trend line. And the linear trend line shows, not surprisingly, that the total volume increases with the total number of transactions. But you don't really get the sense from looking at this graph that you've learned anything. You don't really get the sense that you know something about the data that you didn't know a moment ago. It's not the right format. It's not the right kind of graph. Now, one thing that you might try doing, and this is like the first obvious step, is graph that third column, column E, as opposed to graphing see if the average dollar value tells you something that the total volume didn't. Scroll down. I've already done this. It doesn't tell you very much at this scale either. It doesn't tell you. It's the same problem because the data is highly skewed. You can't see. You can see it's all crammed into this little corner. So what we need is we need a different scale on which to put the data. Once we have the appropriate scale, the relationship will become clear. Now, this scale is logarithmic, and I just want to pause here because a lot of us are a long way from high school science classes where we learned about logarithms. All we mean by a logarithmic scale is that instead of proceeding by equal increments like 2,000, 4,000, 6,000, as you see on the scale below, this is the bottom scale, it proceeds by powers of 10. So it goes from 1,000 to 10,000 to 100,000 in a multiplying fashion instead of an adding fashion. So it's really, conceptually, it's not that difficult. You don't have to kind of get all bent around the axle about it if you just think of it as a multiplier. So we go from, in this new layout, we go from one transaction, which is the left-hand value, and it's the lowest you could get, to 10 transactions, to 100, to 1,000, to 10,000. And of course, we saw, when we looked at the data, there are some with over 10,000 transactions, quite a number of them. So we see there that's where the data winds up, somewhere in the range 1 to 10,000. But the way we've done this, we've grouped them by size, by relative order of magnitude. And we see that there's approximately the same number of transactions in each bin. There's about as many transactions, or at least it seems so from the dots, between 1 and 10, or between 10 and 100, or between 100 and 1,000. When we look at the Y scale, we see the same thing happening. We know that there are occasionally transactions worth $1 or $10, but most of them are worth more. And as we move up the scale, we go from 1 to 10 to 100,000, we see the scatter plot, what this is called. The scatter plot places most of the data in the range from $1,000 to about $1 million in total volume. Most vendors are in this. Okay, so I hope that I haven't sort of lost anybody here plotting this on the log plot. What I want is I want you to see that the trend is now visible. Now we can draw a line through these plots and we can say, look, there's the total dollar volume increases with the number of transactions. And that's a very basic relationship that you would expect to have. I mean, if I asked you just out of the blue, what do you expect? Sure, more volume. Now we can be more precise. We can say, but what's the slope of the line here? How steeply does the relationship climb? We could imagine it steep climbing more steeply or climbing less steeply. We can sit down and try and quantify how much of a climb there is. In particular, we want to know, does volume go up faster than the number of transactions? And you can't tell that from this. You can if you're a mathematician and you look at the little equation at the top. This Excel supplies a trend line equation. And you can tell if you know a little bit of math that this exponential means that it does climb faster because the exponent is greater than that. But I won't subject you to exponential station. I'm not going to drag you all into that. We're just going to look at this drawing and say, yes, there's a trend here. It's going up. Volume and transactions go up together. And we can't tell just yet which one goes up faster. The way we can break it down and determine which one goes up faster is by taking the average instead of the total volume. Now here, we have the transactions as before on the bottom. But we're looking at average invoice size, not total volume. And average invoice size is going up. The trend is upward. That means that a small vendor not only submit your transaction, the average value of that transaction is small. So you've got a linear, or not actually linear, but a consistent relationship between invoice size and vendor transaction. All right, so I've relatively quickly I've gone through the typical way that Excel presents the data, which isn't very helpful, and then this kind of funky log plot, which is much more helpful and kind of illustrates the trend in the data far more clearly. And I know you're asking, yeah, but how do I do that? So let's go back, now that I've shown it all to you, let's go back to the beginning, and we'll just go through step by step, and by the end, you should be able to do this for yourself.
Okay, we're back, and I know the quality on that video was not the best, so I am going to pull it a bit early and just kind of do more of a live presentation of that, and hopefully I come through a lot clearer than Dean was coming through on the taped video. But if you were able to get some of where Dean was going and showing this, for the most part, his plots, which again, you will get these and be able to play with them yourself, it really kind of changes when you're able to go from kind of the standard axis that Excel will kind of send you to go more to a logarithmic kind of axis. And bear with me one second, it just went over there. So if you kind of set it to that logarithmic scale, as Dean was showing, you can get a much different view. And what I like to do, just from now, what is the kind of next step in utilizing this, is to in essence, bear with me one second. I was just looking at the questions just to make sure that the sound quality is back here. Okay, but in selecting items, because you have that trend line, you really can start to look at, well, what is the trend for somebody who is at 100,000 transactions? The trend is that they'll be at this, gosh, what is that? 90 million mark or something, 95 million mark, and sure enough, that person just drops right through there. But there's this other one way up here, for $1 billion, that's way off the curve for the transactions that are there. And therefore, I mean, just kind of selecting items above and below that line, that linear line that could be set. And we did this also in the bear with me one second here, I just wanted to find it. Yep, there we go. Again, in 2007, 2010, you can really quickly add a trend line by going to your chart tool, layout, trend line, and pull that in. That'll calculate that. And again, just kind of looking above and below that trend line is a way to utilize the log plot, and as opposed to kind of the normal plot that Excel will throw you. Okay, I did want to get that concept across. Bear with me 1 minute here. And it's time for the next polling questions. Let me launch that. Whoops. What chart scale is used to improve the graph's readability and provide new insights? Is it regression, logarithmic, proportional, or readable? Which one of the 4 items there? And just giving everybody a few more seconds there to answer it. Most of you have voted on which type of chart scale is used to improve the graph's readability, provide new insights, regression, logarithmic, proportional, or readable. From a questions point of view, I just want to check here if I and I did put it in the chat room there, but the sound quality of the video gets a little bit better with Dean's video when it's out on Audit Software Videos. But for now, I think hopefully you got enough about kind of the logarithmic scale and how it can really change. Bear with me, I just got my questions box back again. I just wanted to make sure. Okay, so we're back on questions. I'm going to close this poll. And share that with everybody. Excuse me, and the chart scale used is the logarithmic, and something that you can get, again, just by, oh, I may have closed it, but basically in the formatting of axis, you could select logarithmic in doing that. So let me hide this part of things. And next on the list, what I wanted to do is jump into some Geo Mapping and be able to show you that. And whoops, sorry, folks. A couple of technical difficulties there. Anyway, we'll be talking about map point as well as batch geo. And I find that geo mapping is just a great way of almost like getting a lot of people's interest. It's a new way of looking at things, even though it's really not. It's an old way of looking at things, but it's something where putting things on a map can give you insight about your business, business partners, be it vendors, where they're located, where around the world they're located. Where are they collecting more so? And this might be a good example, supplier value by street address. You can kind of get a sense of where some of the larger items are and where some of the smaller items could be, and where there's a lot of concentration. And you really can drill into that, and that's what we'll be showing you in the next few minutes. But for the most part, you have really two options going down the map point approach of having it saved on your computer, and that's something where you're not really uploading it to say MapQuest or Google Maps or something. Batch Geo is more on the web, which will show you that, but you're uploading your data to the web. And that's a real key difference here between MapPoint and the other. MapPoint is a Microsoft product, pretty good. I have to say I think the Google mapping is better. It's more functional. But yeah, with that said, let me just kind of queue this up so that we can check this out. And it should go for just, gosh, how long here? About 8 or 10 minutes, kind of showing you geomapping and how that could be used as a graphing technique for a lot of data that you're utilizing. I used to use MapPoint from Microsoft, and it's not a bad product at all, and something to utilize. But I've moved to another product that I think is a bit better and a little easier to use. Now, MapPoint, the one good thing I'll say is that it tends to stay on your computer, and the data stays on your computer. So that's a little bit better than what I'm about to show you, where we go out to the web. But with that said, I think a lot of the data that we're sharing here probably is not that problematic, and that it usually is just address information without names that kind of thing that's kind of public in some way. So the Geo Mapping, though, is something that is useful. You can do things like, as we'll talk in a second, this is showing it by value, and you might want to take a look at by value where things are. You can do it by score, which is what we're going to do in a second. But what's interesting is to look at pockets or areas where, in this case, there are not that many, but let's say the blue is from a million to 10 million. You can see a few of the blue areas showing up, and those are, some of which are in areas where they have like low scores or low values. And you kind of want to look for those areas where you have this just huge value showing up somewhere, but yet there's not a lot of other values showing up elsewhere around that particular item. So what I'm going to end up showing is geo mapping using batch geo, and what we're going to do is put out there the address, the city, the state, postcode, and it allows you to kind of select how you want to score the data. You can basically say group by the thematic or thematic value, and you can select total score. So this data I can't so much send you, so I'm just showing it to you today because it does have addresses and that kind of thing. But again, the fact that you're just putting the supplier number, addresses, and maybe a score, it's probably not too private in that way and concerning. And Batch Geo, which we'll show you in a second, I just think is a great product. We're going to create some graphs that look like this, and it does it pretty easily and quickly. So bear with me 1 minute, and we'll bring that up. So what I ended up downloading from their website, and let me just open this file up for you, and I can provide this to you because it came right from them. They actually provide a list of addresses, and I guess they're the Apple stores that are out there. And sadly, Steve Jobs who's listed here, so they haven't updated that yet. But the URL is also there for each one, and there are a variety of things that we could do with this data. I was going to show you something a little more useful, but again, this is actually the template they give you, and they say, hey, if you fill out this template, you don't even have to fill out all of this. You don't have to put the name in there, for example. You don't have to put phone number. You don't have to put group or URL or email. Even if you just have address, city, state, zip code, and total score right here, that would be just enough to kind of get this thing to run. And let me just go over to Batch Geo here. So I just opened up a link of data that I uploaded, and it had addresses and total scores. And what's interesting, you can look at this map. There's nothing wrong with it, but there is some data points that are showing up in other countries, and you might not realize sometimes that you have business partners that are in other countries, and that might throw you a bit. And you say, we didn't realize that. So that's something to look into as a first point. I mean, obviously, a lot of the data is showing up in the U.S. Here, but we do have a few showing up in other areas. So let me scroll in, and what's interesting, what this is showing us is the total score, and it is basically colorized down by the section or the dots below. So, the blue, which of say the 673 in the middle here, that's kind of high. I'm sorry, so it's going to scroll in and take a little bit. Hold on 1 second. So that those graphs will change as you get closer and closer in. You can see that the blue of let's say, let me pick something, let's say out here in Washington on the left, we have 82 vendors in this case, and of those 82 vendors, there are blue ones that are with a score of 0.98 to 0.08 to 0.98. Now the red, and there's not a whole lot, there's a couple here showing up in the Minnesota, Wisconsin area, so I'm going to scroll more into that area, and as I do so, you can actually start to see more of the red dots showing up because that's where that is showing up more in the graph. And as you scroll in more, you can start to find, oh, okay, that it's really part of it is in Illinois. Just kind of click on that one. It gives you a little bit of information and the total score here. There's other ones here where you can click on that one section. You can click on that one chart, and then it gives you that whole mapping of that area for that one chart. Now, What I like about this graphing is, it's very interactive. You can scroll in, scroll out. I think you even can get to satellite pictures. So it's something where if you did find a particular, let's say red vendor, you can click on that vendor, but then get a satellite view and actually say, oh, that's interesting. We're paying $18 million, and it appears to be being paid to an apartment building. Not that that's wrong, but it's just odd, that's where the payments would be, would terminate basically. So another way of looking at this too is to go down to the total score line item down below here where you have all these map pointers, the legend. You can select any one of the legend points. In this case, I selected red because they're the biggest ones. And it actually highlights not only red ones, but also which ones are bigger than others. And the bigger ones are obviously, like this one here, should be the 74.1 score, which is the highest score on the legend. So that's something where you can easily kind of highlight certain scores and then just click into them to gain more information about them. And I think just given the limits of internet streaming today, I'm not going to go as far as getting into satellite and terrain, but I think everyone gets the picture. And Batch Geo, let me just kind of zoom out of this for a second. And I might even just, bear with me, I'm just going to redo this whole thing and just go to batchgeo.com just to show you how to do this. All you do is paste your information into this screen right here. And you can click and paste it right from that spreadsheet they give you. You don't need to have all these fields. As long as you have a few, it's pretty smart. It figures out city and state and all that stuff. And then the total score, it doesn't know what to do with that stuff, so it ends up putting it into that section. Hey, let me just highlight. Let me just turn this into score, and we'll put 100, 75, 50. Just do a bit of a bell curve here, like probably everyone expects. 15, 15, and 10. So if I just take this address information with the score, copy and paste that, and go right into my Batch Geo, I can highlight this and do a Control-V, and that brings that in there, and I can say Map Now. And it will map this information. It takes if you map 10,000, which I think I did a few thousand in that mapping you were talking about, it'll take a few minutes. I mean, it's something where you need to give it some time. Now they have a professional version that's more secure, and also something where I'm sure it works a lot faster than the free version that I'm working with, but it all works, so it's something to look at. And the markers themselves show up, the scores themselves show up. In this case, there's not that many, so we're not really getting all of the, just look down. Oh, if I save and continue, I can save it and say, test map. And I don't know if I have to do all of this, but I'll just put my email in here. Just wanted to show you the final, what it usually does is it was pretty smart, but it then sent that to me. I think, though, as I scroll out of this a bit and just kind of go down, it does show not only the graphing, but what's really nice is you can actually download this map to a KML document. And if anyone has Google Earth, and I have it in here somewhere, so I again won't open it up because it's going to create a whole internet download that we don't want right now. But that Google Earth will actually then bring up, you can then upload this KML document to Google Earth. And Google Earth, I find, even has even better mapping features and abilities to look at particular items much quicker and succinctly, but also to get much more detailed information, what's surrounding it. You can get pictures from a 360 angle point of view. So the mapping part of it I find very interesting, only because it gives you a lot more data about people that an address record does not give these days. You can get a lot more information by taking a look at some of these mapping type software. Okay, so we just wanted to launch the next poll, which software processes address mapping on your PC? Would it be MapQuest, Yahoo Maps, which is spelled wrong there, sorry about that, Batch Geo, or MapPoint? So MapQuest, Yahoo Maps, Batch Geo, or MapPoint. Which maps on your PC? And again, just kind of looking at some of the questions coming through. Hopefully the sound is getting better. I'm not precisely sure, but hopefully it's getting a bit better. I'm live from this point forward, so this is how we will sound for the rest. And we'll be going through a few things in just a minute or so, or a couple of seconds. Okay, so let me close the poll and share that with everybody. And actually, the one that does it more so on your PC and keeps it on your PC is MapPoint, but you're right, Batch Geo is the other product out there, the two that we talked about, and that's what everybody's clicking on, so that's good. You're listening, and that's all that's for. So, okay. I just need to show my screen. There we go. Excuse me. Okay, so I wanted to walk through a Benford's Law testing that became a graphing exercise, but then show you how it really relates to some of the other best practices I wanted to talk about as kind of closers, which are more just in making your graphs look a lot better and improving kind of the readability and why you're going to use certain graphs over another in that. So bear with me 1 second here. What you'll notice, and we're going to talk through a few different topics as we go through this, but as we go through this Benford Law scoring tool, you're going to see how the data points in the data series exceeds kind of the limit of Excel. And these are some of the limits here, from a charting point of view that you need to be worried about. For the most part, you can't exceed 32,000 in a 2D chart. So if you're doing like a scatter graph, like we'll do in a minute here, you'll see how that comes up. And then, I guess ultimately you can keep adding additional data series is what we're going to do. And again, kind of going back to, if you have too many data points, what do? You basically exceed that 32,000. We still can work with it, and I'll show you how you do that. Again, these are some of the other limits here. Not back to the polling question, but let me go into this Excel spreadsheet now so that we can work with it. And I actually need to open it up. Just takes a second. There's a lot going on in this Excel spreadsheet, so while that happens. Okay, well, one of the previous videos that we've done in a statistical course that we gave back in May actually it was back in July. July 18th was the date, and I actually have it in the data file there, so that's when we gave it. But this was a great little tool pack that, again, you can get if you went to the course, but I'm happy to give it to you as part of this course today as well. So what we're able to kind of show here are quite a bit of summarizations and pivot tables that have been kind of pulled together. What I mainly wanted to show you, and just bear with me 1 minute here. And I thought it was in the sheet, but maybe I am, yeah. Give me 1 second here. I must be just missing the actual graph that all right, bear with me 1 more second here, because this may answer. All right. Well, you know, I can show it to you here. I'm just a little taken aback because I could have sworn within here I actually had a way of showing you how to split the actual file. But let's take this one here. Whoops, sorry. Nope. This one here. So this was the scatter and other graph template, so it wasn't the Benford Law template to work with. And in this one, what I've done is I've created 2 data series. And the reason I've created those 2 data series is because I got beyond the Excel limits that Excel wanted me to work with. And what you can do is kind of set up 2 different data series. So, you know, in going through your data, you let's say, in this case, we're actually graphing columns I and J, and just kind of graphing that. You're welcome to make a you know, 1 data series and kind of make that chart. Let's just insert a small chart, a small scatter graph here. And in that chart, in selecting the data, you can actually add another series name, and you know, for the most part, you can not making it as easy to select here, but what I was hoping to do, you know, was to bear with me 1 second. Okay, so you know, I can then select a set of X values here, and just kind of go up, and probably the easiest thing to do actually is just to, if I can copy this, which I always had trouble, oh, there we go, if I can copy that down here and just move it over by 1 column, so instead of it being I, it would be J in this case. Now I have kind of Series 1 and Series 2, so if you do exceed the limits, let's say 32,000 in your limits, it really, where did my chart go? There it is. Notice how in my chart now I have 2 data series. So I have Series 1, Series 2 that we basically just kind of quickly set up there, and I just pulled a few items really just to kind of prove the point. But if you do get something where you're going beyond 32,000, or Excel is telling you that you're exceeding limits, this is a way of fooling Excel and kind of creating multiple series, you know, 1 to 31,000, and then beyond that into other areas. But again, just kind of wanted to show you the main point of showing this is actually to note that you can kind of bend the limits of Excel a bit. As you notice, though, the largest limit that they had was you could only have 256,000 data points, so I guess you could only have, you know, 32 times whatever to get to 256. So you know, you have a fair number of data series that you could post, but if you have 1 million records or so and you wanted to put that into a chart, that's going to have trouble in Excel. And with that, what I wanted to do is I'm just going back in my slides here, really just back to a point. And I wanted to close on this because I thought it was more of an interesting kind of topic to close on. And we're going to go around a little bit on the web and also, excuse me, take a look at a variety of different graph types. But, you know, Dean Brooks's log discussion hopefully was interesting to you, and again, listening to the video should help as well. But Edward Tufte has a website out there, and I tried to copy the link into that, that page there so you can see it. It's edwardtufte.com, and I'm actually going to go out to his website right now just to kind of show you that website. Bear with me one second here. There we go. And, you know, I've bought a few books by Edward Tufte over the years. I found, this one's kind of funny. Hold on a second. I can't get back. I think it was book number 5. Yes. This is one I thought was really interesting. I'm just going to scroll into this so you can see it. Is Visual and Statistical Thinking, Displays of Evidence for Making Decisions. And again, Edward Tufte, I believe he's at Yale University, and is just a wizard at kind of playing with graphing and how to make like a very simple graph, but yet make it very effective. And that's sort of what I want to close on in concluding here, and really just to kind of get you to see some of the benefits of some of the different types of graphs. And again, Edward Tufte, you know, I haven't really explored his website. Bear with me one second. To see, but this book here is $7. So, you know, he's really come down. I bought some hardcover copies of the books, and you know, they're more like in the $40 range, like this one is. I do have this one here. Bear with me one second. But kind of great to inspire you to do very useful graphs. And, you know, when we are talking about cleaning up, these are just some of the things that I wanted to show you. But I have to say, you know, what I wanted to spend probably about 5 or so, at least, minutes on was taking a look at the different types of graphs, and again, more down the road of like Edward Tufte and which one to select, and then kind of cleaning it up with these final points of removing grid lines and white space, you know, having white space and chart styles and layouts, which really can very quickly make your charts look great, and then saving your charts as a template so that you can kind of keep them for the future. Bear with me one second. Now I'm going to just go back into Excel. Okay. And I thought that this was a good example. Bear with me one second here. Okay. So, you know, just taking a look at some of the charts you may have. This one is more in a way of like a bit of a pie chart. Each line, or you know, each bar here or column here, which is now in 3D. You know, you kind of wonder to yourself, do you 3D or not? You know, it's sort of it's up to you as to whether or not, you know, that makes a lot of sense to do. But something where sometimes some of the 3D stuff can look quite nice, and you know what I sometimes prefer, though. Bear with me one second. Is you know, maybe another way of looking at it is something like this, where I don't think is as useful, you know, of a chart. It's sort of hard to quickly pinpoint things. So taking a look at this particular column 1, which, you know, again, is just kind of working off of this 3D kind of pie chart, whatever, where that's hard to read. kind of going to still hard to read but getting maybe a little bit better. You can identify certain months by looking at the actual columns or excuse me, the bars within the columns. There we go. So, and taking a look at ones that are larger, you know, September 2009, I think that's what that one is, and that does look quite big. You know, some other ones look kind of small, etc. So that, you know, that's kind of useful. But I think it's almost more useful, and this one, mind you, we filtered, so let me just select everything and then go back to this. You know, I think the line chart does a much better job. You know, so it's almost like what's your option. You could use this option to kind of figure out where the months are, where there's large deviations, or you could use something like this, where again it's something where just by the very nature of the line versus the kind of like stacked column, which was the other one that we were just showing, it really kind of pops out to you as to where the largest items are, and kind of, you know, what is that time frame from, say, March to, you know, February of the following year in that data. So, you know, just kind of showing you that, and then you can get really kind of elaborate and get more to the 3D option of that, and you can actually just right-click on any sort of 3D chart, click 3D rotation, and I'm not going to do this well, you know, I'm sure, but just by sort of playing around with it, you can change how sort of dramatic it is and whether or not you're underneath it or above it. And it's kind of, we'll leave on that one there, but again, you know, pretty dramatic, and it's probably harder to line up actually where December is. You know, just kind of going on some of the making things look nicer. Aside from formatting the axis, which we'll show in a second, you know, formatting grid lines, either to not have any line at all, it might be an approach, and you know, sometimes it's a little nicer to kind of have those grid lines. And I think one of the scatter graph ones that we just showed a second ago, if I can find this one, you know, this one, sometimes, you know, having that actual graph paper is quite useful of knowing exactly where something is. And, you know, I've watched my children in math class, you know, pull this one together and figure out, you know, how many over and how many up. So, you know, again, I do think the use of grid lines can be a good thing in some graphs, I guess is the point on the grid line point. But in other graphs, it you know, may kind of hinder your actual view of what you're trying to look at here. And I think the type of graph, again, I think playing around with it a bit, you know, just kind of right-clicking on data and changing chart type. And you know, again, really, I'm just now truly playing around here. You know, okay, so this is kind of an interesting, you know, skyscraper approach to looking at things. It's kind of hard to see some of the things back there, so, you know, again, by right-clicking 3D rotation, you can kind of bring that probably more in line to focus. Yep, it's really kind of, it's sort of hidden. Some of the buildings hide the other buildings in the actual chart, but still, I mean, there's still something to be said for building a pretty intricate, you know, looking chart that you know, that you can utilize. And one of the things I wanted to note is, let's just imagine you really like this whole skyscraper approach, and there's no reason why, you know, a lot of time here for all these thoughts, but you can kind of change your background of this and put a skyscraper to make it look, you know, truly authentic here, if you'd like as well. But once you're done with that, one of the things that you could do is save it as a template, and that's something where, you know, if you got comparable data, that graph template is something that you can utilize. And well, I have one in here, but, you know, maybe I'll call this the 3D chart or something like that. May not always work with the data that you're, you know, trying to put into it, but it'll tell you that. And, you know, once you've saved it, I need to, let almost need to remember how to do this exactly, but I believe you go all the way down and maybe into Manage Templates, and it's way over here. And you can actually, so when you say Manage Templates, it comes up. You can select 3D chart, and now I'm saying it can't open the file, so that's not good. So let me try to, here's my template. So by selecting the template section, you can actually, maybe we'll select this one here, and it brings it up. I don't think, though, that other template, the scatter graph, I don't even think I could use it. Yeah, so it's going to tell you it can't use it, or it's going to save it. But that sort of template approach can save you a lot of time in building some intricate graphing and then wanting to kind of bring it to another audit or another type of audit, but still doing things like stratifying by type. Of month and year. Okay. And there's nothing to be said. Probably one of my favorite charts out there, and I think I'm going to have to start over on building it for you because I'm surprised I actually don't have it in here, and I don't. Yeah, one of my favorite ones to do, so I'll kind of walk you through building a chart very quickly here. Let me just grab that data. And I'm just going to do that to a new worksheet and build a pivot table. And what I'm going to do is bring in just the enter date over to the left-hand side. And you could do anything, but probably just even bring in the invoice amount into the values section. And I'll change the values by right-clicking and changing the format of that field. And now it'll look a little bit cleaner for purposes of what we're going to do. Once I have that pivot table set up, and this again, this is more of the basic stuff, but I wanted to just note it, you just select Pivot Chart, and at this point I would select something like a basic line chart would be fine. I guess we could go 3D, but I won't. I'll just keep it basic. And I'm going to move this chart to its own kind of section. And I find this is one of my favorite graphs to run for any process, accounts payable, general ledger, inventory, you name it, is truly just what is the activity per day? And, are there exceptional days to go take a look at? Invariably, you do find December 10th, December 8th, 2010, December 6th, 2010. You have a high spike upward, a high spike downward. It's very kind of curious and interesting. So, I find that that's one of my favorite charts, actually, of all the things. As we were looking at kind of some of that time graph, I want to note that. Just close that up. Yep, that's what I wanted to do. And I wanted to show you in this particular chart, which looks a little tough here. I'm going to try to say no lines for grid lines, and actually, I know what I did for this one. In order to kind of make this a bit messy, let me go back to this one that's a little bit cleaner. Notice how this axis is $20 million, and it's this, 20 million. It's really kind of large on the screen here. You can go to the format of your axis, and in the numbers section, this is what you'd be entering in, and I believe it's saved in the sheet, but it's basically 0.0, well, actually the better way to do it is 0, comma, comma, quotes, M, and then quotes. And what that'll do is it'll actually, should work. I think I had to apply it, and I didn't apply it. I want to add that and close. And why is it not formatting it? Bear with me. Well, I'm having trouble changing it back. I had it at 20.00, and for some reason, it's kind of keeping it at that level. Huh. And let me add that in there. Aha, okay, perfect. So I guess I wasn't adding it into the library there, but once you've created a bit of a custom one like I've done here, you can see the negative 10 million, the 10 million, the 20, but it doesn't take up as much space as it used to on the page. So cleaning up your formatting of axes can really help a lot as well. Again, some people like grid lines, some don't. I believe the formatting in the layout section. Bear with me one second, not in the design section. Okay, so you have the opportunity here to change chart layouts. Oops, sorry. So that was probably a bad selection there. Sorry about that. But this was one that was actually pre-selected. But you can actually, for every graph, Excel saves a bunch of these kind of interesting chart layouts that you can just click on, and this one here does all of the regression analysis and linear coefficients and all this great math stuff, and all you have to do is kind of press that button. So that's the chart layout. And from a style point of view of just making it pretty, probably shouldn't have selected that, but you can select a variety of different styles to determine what do you like the best, and again, probably the best thing to do is once you've gotten something you like, I would save it as a template, and make that a template that you can use over and over again. Okay, so that pretty much brings us through all of the best practices, as well as kind of going through this Benford Law scoring. Something that just what I didn't touch on as much in the Benford Law scoring, definitely something to take a look at. And if you we'll send you the data file for it so that you can play with it. But I really kind of liked building the score. I just wanted to show you. This is more of using that logarithmic kind of methodology. And I think this one was, nope, this one is more of, well, both of them are the logarithmic, sorry. I think this is where we ended up using what was just in natural Excel, and then this ended up being more the log function version of it. But this is something where, again, I think that log concept that Dean brought up as well can prove interesting. And this Benford Law data table that we do provide you also provides a lot of kind of interesting points on the log function itself. So what chart type is most used to chart Benford's Law scores? We really, for a lot of the scores that we talked about in all of our charting, but definitely for when you have a lot of items, and that's what I was trying to get at, where you have a lot of items that you're graphing. Is it the bar, the scatter, the line, or the radar? The bar, the scatter, the line, or the radar? And just looking for questions, not really seeing any questions. Hopefully sound quality is a lot better, and everybody's learning something. Okay, most of you have voted. I'll just give it just a couple seconds more here. Okay, so I'm going to close the poll, and as most of you noted, the scatter graph is the best. I mean, definitely when you have a lot of data points that you're playing with, the scatter graph really is the best one to work with, and can handle the most data points, actually, of all of them. Bear with me 1 second, just bringing my slides back over here. Okay, well, I am at the end of my presentation here. We wanted to thank everyone for coming today. If there are any questions, we'll be going through some final wrap-up points here, but if there are any questions, we really do welcome them.
Thanks, Rich.
And, yeah, sure, John.
Thanks. Great job. And again, we apologize to everybody for the audio on Dean Brooks' recording. The information is very valuable, but I can understand the concerns that were raised, so we apologize for that. And if you do have any questions, please feel free to submit them. Rich is an expert in using Excel for auditors and also in other areas of data analytics and audit software. So, you can see right there, Rich had a screen up for active data for Excel.
Sorry.
It's a tool that maybe you could tell them a little bit about it, Rich, and what you've put together for them as far as training and books and.
Yeah, and thanks, Jim. Yeah, I mean, active data, I didn't have as much time to show it in today's presentation. Kind of glad I didn't, in the way that just to show that good old Excel, can do this. But active data can be used to do a lot of summaries for you and be able to kind of bring data much closer together so that you can analyze it. Wanted to also note, I mean, active data for Excel has a discount through AuditNet, and the link, I believe, is in there, and we can get that for you. It's usually on the video page as well. As to the video page, yeah, do give us about 7 or so days to get that up there, but that should be up that sooner than later. You can watch it for 12 months. It's kind of broken down into about 10-minute video segments, and you can buy others. I mean, the past graphing course you might want to take yourself, and other things like that. So there's a lot out there. I think we have probably about 50 or 60 hours now that is taped, and something that you could just watch 24/7.
Yeah, excellent. And I had actually posted a post on LinkedIn today about the value of having the recordings. And research has shown that most people that attend training, they lose probably 60 to 70, perhaps as high as 80% of what they learned during that seminar or webinar when they get back to the office, because they just can't retain it all. And these videos are a great way of having just-in-time training, and it can reinvigorate and refresh what you learned by attending a webinar. And we find that it's a valuable way of auditors to learn, especially the area of data analytics and the use of audit software. So, Rich, if you want to add anything to that, feel free.
No, that's all there is. Yeah, please check it out, everybody. There's like a 2-minute video right on the website just explaining the value of it. Definitely check it out, and thank you. Also, I think the survey's still out there, Jim. I keep asking that.
Yes, it is. That survey will be out until probably until the end of this month. So you can help us out, take that survey. And we do have another webinar coming up. We did have to reschedule it. It was scheduled for January, but that's going to take place at the end of or beginning, I think, the 1st of March.
Yes.
Yeah, March the 1st, and that's best practices in audit software implementation, and that'll be a free CPE event. So we look forward to seeing you all sign up for that. Information is available on the AuditNet site. And with that, I'd like to thank you, Rich, and as well as those who have joined us for this webinar. We're glad you could participate and hope the session provided you with value-added useful information. Just a reminder, you will receive an evaluation form after the conclusion of the session. Take a few moments to complete it when it arrives, as it will help us improve the webinars. And again, for more webinars focused on ACL structured learning as well as Excel and other software for auditors, you can visit auditnet.org or you can visit auditsoftwarevideos.com. And you'll find a lot of value-added information. So if you have any additional questions, please feel free to send them to us. Rich has got our contact information up there on the screen. And with that, I'd just like to wish you all a good day and hope you have a great weekend, and look forward to having you join us again. Thanks.